So hopefully you understood those relationships. You feel like you're getting that. So we're going to pull together this idea of being able to go within a molecule and figure out a relationship with Avogadro's number. Determine the number of atoms of S in this many moles of him. So we have 2.5 moles of CS2. And then notice, we immediately write moles of CS2 on the bottom. Once you have moles of CS2, you can jump to someone else. Moles of S, again, drop it onto the bottom. And then it's asking about atoms. And that's why we put atoms on the top. Now, we just assume 1 mole of this and 2 moles of him. Now, can you pick other numbers? Yes. So I could have said in 5 moles, so in 5 of those, there's 6, and then times 5 is 10. You can pick any number, but it gets complicated. We just want some relationship. So it's easiest to pick one of the big whole thing, and then you can turn it into the smaller thing that's inside of it. And then again, remember this is Avogadro's number. Then when we put it on our calculator, we'll have 2.5 times 2 times 6.022. I'm going to use my E key, second E, 23rd. So it gives me 3.011 times 10 to the 24th. Let me check my sig figs. 1, 2 sig figs. This is a perfect relationship. It's considered exact because it's an exact amount of atoms in exactly an amount of a mole. And Avogadro's number's got a lot more numbers in it. So I have 1, 2, 3, 4. I need it to just have 2. So that's what I'm going to go to. And the 1 does not round up the 0. So the answer should be 3.0 times 10 to the 24th. So you're going to do that problem. But I'm going to go ahead and demonstrate one more. So what this did was it took that concept we were just talking about and turned it into atoms. Now we're going to take that concept and we're going to turn it into grams. So I have 2.0 moles of H2O2. I'm trying to figure out how many grams of O2 that I have. Not O2. Sorry, it just wants to know of the atoms, so of O. Of individual atoms. They're not saying oxygen molecules. It's one about the atoms. So I'm going to go for moles of H2O2. You always know the first step. It's straightforward because it's got to be. When I'm at moles, I can go to moles of whatever's inside of it. So moles of O. And then immediately drop it down, moles of O. And those two are going to cancel. The units are. And then it wants to know about grams. I can definitely get to grams of O. So again, the larger thing is going to be 1. And I go inside, there's 2. And then this is on the periodic chart. So if we want to look over the chart, and I look up oxygen right here, 15.999. So if I'm doing 2 sig figs, that rounds me to 16. That's what our chart says is 16.00 in 1 mole. I'm going to put that in my calculator. 2, you can do 2.0 times 2 times 16.00. That gives me 64. Let's check my sig figs. 1, 2 sig figs. These ones don't count. They're exact because it's exactly that many moles and exactly that many moles. And this from the chart, and that's got 4 sig figs. So that is correct on my sig figs. So practice this problem and this problem.